So there's sometimes that you're gonna need these types of special products of polynomials. So in a case like this one, um, this a plus b times a minus b, there's no need to use FOIL to figure out the pattern. Right? Same thing with these two. The patterns are already there. There's no need to do a whole lot of extra work. Okay, so make sure you guys copy those down for yourselves, because we will go back and use them. Alright, and the reason for them is, if I were to give you a problem like x plus 10 times x minus 10, normally you would start using FOIL, double distributive property, you'd use the table, and you would start multiplying. Well, there's no need for that anymore. X plus 10, x minus 10, we can look and see it's just the sum and difference pattern. Alright? Same thing is if you're given a problem, and we'll go back and we'll look at these more specifically. Another thing is, if I were to give you x plus 3 squared, we can now look at it and just see, oh, it's this one right there, and there's nothing special that you're going to have to do. Follow the pattern, and you'll be okay. Alright, so let's start looking at some examples. So example 1, the directions. Find the product. Right, and again, you're going to be referring to these special patterns in these problems. So I gave you x plus 3 squared. Now, we look at it, and instantly x plus 3 squared, so something plus something squared, there it is. Well, I really want you guys to understand what this means. What this means is you have x plus 3 times x plus 3, and you're writing it out twice. And if you were to use the table, FOIL, double distributive property, you're going to get x squared plus 3x plus 3x plus 9, combine like terms, x squared plus 6x plus 9. Now what I want to do is I want to use this special pattern here. I want to use this special pattern right here. And you're going to see we're going to get the same exact answer. But I really want you guys understanding, when you write this out, when it says squared, you're writing it out 2 times. Alright? You're writing it out 2 times. Let's say a test or a quiz, you forget this pattern, you can always go back to FOIL or double distributive property. Alright, so let's look at this problem again. X plus 3 squared. Now, you notice we have an A and a B. Alright, well, I want to write that out. A equals X, B is equal to 3. Now if I start to follow this pattern, it told me A squared. Okay, so A squared is X, so X squared, in parentheses, plus 2 times AB plus 2 times A is X, B is 3, plus B squared, plus whatever B is squared. Now let's go back and look at this thing. X squared, well, it's just simply X squared. 2 times 3 gives me 6. and then 6 times x is just 6x, plus 3 squared is 9. And I want you seeing same exact answer. Okay? I don't care which way you do it. I'm trying to show you the patterns so that it becomes quicker. Right? And it's nice when you start to recognize them later. Right, so here's another one. 4x minus 2 squared. Well, in this case, it's a minus, so I'm going to look at that one. Right? Because I have this minus, I'm looking at that bottom one. Same thing. A is equal to 4x, b is equal to 2. Don't put negative 2, just look at the numbers, or whatever's sitting there where b should be. Alright, so then the pattern. The pattern says a squared. Alright, so whatever a is, so I'm writing down 4x squared. Sorry, I'll run out of room here. 4x squared minus, right, you see the minus here, so minus 2 times whatever a is 4x, b is 2, plus, don't mess that up, plus 2 squared. Alright, let's clean it up a little bit. 4 squared is 16. X squared, well, simply x squared, minus 2 times 4 gives me 8. 8 times 2, 16. X plus 4. Now I want you to hit pause, and I want you to try this one. 5x plus 2y, the whole thing squared. Alright, keep in mind what what a is and what b is. So hit pause, you try it. When you're done, hit play. Alright, I hope you had some success. So I see the plus, so I know it's going to be a square of binomial pattern. So it's going to be this one. Alright, a is equal to 5x, b is equal to 2y. Now, I'm just gonna start writing the pattern out. So it told me ay squared, so in parentheses 5x squared, plus 2 times whatever a is, a happened to be 5x, whatever b is, 2y, plus whatever b is, 2y squared. Now you notice anytime I'm substituting, I'm putting in parentheses. I'm trying not to make any mistakes. 5 squared, 25x squared. 2 times 5 gives me 10. 10 times another 2 is 20. So 20, I have an x and a y. Alright? Don't miss that. You have an x and a y. And then plus 2 squared is 4. Y squared, simply y squared. Okay? Now again, these patterns are nice if you don't remember it. If you don't remember the pattern, you can always write this thing out 2 times. Do not forget that. 5x plus 2y times 5x plus 2y. Use FOIL, the double distributive property, the box method, whatever you need to use for yourself. Okay? But just recall, this thing is squared. So you would write it 2 times. Alright. Now I want to try I want to try that other pattern. So example 2. As you recall, I gave you x plus 10 times x minus 10. Now we could use FOIL, multiply it out. So I'd have x squared, x times negative 10, negative 10x, 10 times x, plus 10x, 10 times the negative 10, negative 100, and then we notice those two things, those two terms cancel each other out, so we're left with x squared minus 100. Alright, but if you recognize the pattern, so recall from, hopefully you wrote these down for yourself, so then you recognize the sum and difference pattern. Alright, a plus b, a minus b just gives us whatever a is, you square it, minus whatever b is, you square it. So let's go down to the problem again. So I want to do the same exact problem, showing you the sum and difference pattern. And I don't care if you don't remember it. Remember the name of it. But a is x, b is 10. So what was the pattern? A squared minus b squared. Well, x squared minus 10 squared. So x squared minus 100. And again, you notice exactly the same thing. It's quicker if you recognize it. Okay, it is a whole lot faster. So I'm going to give you one to try. And again, hit pause, you give it a try. 2x plus 3y times 2x minus 3y. You notice a and b are exactly the same, it's just the signs in between. So hit pause, you try it. Okay, let's start going through it together now. So a is equal to 2x, b is equal to 3y. Well, as you recall, the pattern said whatever a is, we square it, minus whatever b is, and we square it. So 2 squared gives me 4, and then there's my x squared, minus 3 squared gives me 9, y squared, there it is. And you're done. Alright? Now example 3. We want you to write a polynomial that represents the area of the square. For you guys that have been doing this table feature, this table method, this is going to be nothing to you. Alright, so you notice it's a square because x plus 6, x plus 6. Same dimension, so we know it's a square. Alright, so now, what's the area of this thing? X times x, x squared. What's the area here? 6 times x gives me 6x. This area, x times 6, there it is, 6x again. 6 times 6 right here gives me 36. Now, thinking about that pattern that said a plus b squared, because essentially that's what we have, it gave us a squared plus 2ab plus b squared. Now let's think about it. A squared, here's my x, right? So there's x, so that would be a, and then when we use the pattern we get a squared. Alright, there it is. So I have x squared. Now this 2ab, well, what that's saying is I have 1, 2 of those, so I have plus 2 a times b, or 2 of those 6x's, and then b squared, that would be the 6 times 6, which gives me 36. So then we have x squared plus 2 times 6 is 12, gives me x plus 36. Alright, so again, for you guys that are using that table feature, this is going to be very easy for you. Here's one that's a little bit tougher, and forgive my horrible drawing, but if I gave you x 5 and 2x. And I'm attempting to keep this square because the dimensions are going to be exactly the same. Let me try that one more time. Apologize, I cannot draw. Alright, so here is that. Here's for x. There's for 5. Alright, now you guys hit pause. Try it. Find the area. Alright, so hopefully you had some success. So there's x squared. There's 5x. X times 2x. 2x squared. 5 times x. 5x. 5 times 5. 25. 5 times 2x. 10x. 2x times x. 2x squared. 2x times 5. 10x. And then 2x times 2x. 4x squared. So we'd have to put it all together. Now let's keep track of everything that we've used. Alright, so x squared. Let's write it down. And then 5x. But if you notice, there's actually 2 of them. Do you agree? Alright. So 2 times 5x. And then if we look at 2x squared, there's actually 2 of those. So plus 2x squared. 10x. Well, again, there's 2 of those. So plus 2 10x. And then I have 25 and 4x squared. Let me write those 2 down. And I apologize if I run out of room here. Alright, so plus 25. And I apologize, let me squeeze this in down here. Alright, now let's go through and start combining like terms. I have x squared. Well, you know what? Wait, before we do that. Excuse me. Before we do that, we got to clean it up a little bit. X squared. 2 times 5x. 10x. 2 times 2x squared. Plus 4x squared. Plus 20x. Plus 25. Plus there's a 4x squared. Alright. Now that after we cleaned it up, combine like terms. 1x squared plus 4x squared gives me 5x squared. 5 plus 4 more gives me 9x squared. And then let's look at the x terms. 10x plus 20x gives me 30x plus 30x. And then that last term, the constant of 25. Now, is there a way that we could have gotten this a little bit easier than having all those terms? I'll let you think about it, but hopefully this little hint would help you.